Hello, you wonderful Algebra 1 students. This is Mrs. A, and I love math. And tonight we're doing lesson 24 in your orange book, and we are talking about multiplication property of equality. And basically, the multiplication property of equality can be used for multiplication and division, because we know that division is simply multiplication by a reciprocal. So any rule that we have for multiplication, we can use it also with division as long as we are keeping the division in its own spot. We'll talk about that more later. But here we start with A is equal to B. Okay, that's a true statement. If A is equal to B, then we can have the equal sign there. The equal sign means that the left-hand side is equal to the right-hand side. True? Okay, so now what we're going to say, if A is equal to B, then if we have some constant C, we can multiply both the A and the B, both sides, by C, and we should still have an equivalent statement. In other words, suppose A was 2 and B was 2. Then 2 equals 2. And if we multiplied both sides by 3, we'd get 2 times 3 on the left, and we get 2 times 3 on the right, which means we would get 6 is equal to 6, which is a true statement. So what they're saying here is, just like when we did the addition property of equality, said that we could add or subtract the same thing from both sides of an equation. An equation, by definition, means that the left-hand side equals the right-hand side, okay? Or we could not have that equal sign there, right? So in an equation, if we do the same thing to each side, we should come up with an equivalent statement again. So we start with two sides equivalent. We do the same thing to both sides. We wind up with the same equivalent situation. Okay, 2 equals 2 is true. 6 equals 6 is true. I just multiplied both sides by 3. Okay, if I had 2 equals 2 and then I divided both sides by 2, then I would have 1 equals 1. Still true. Okay, so you could summarize the multiplication property of equality to say this. If every term on both sides of an equation is multiplied or divided by the same non-zero quantity, the resulting equation will be an equivalent equation to the original equation, and thus every solution of one of these equations will be the solution of the other. Remember what we talked about when we did the addition property, that we solve by finding simpler and simpler equivalent equations. And our job is always to get the x by itself. All right, so I have an example here. 4x is equal to 12. Now I can do this two ways, and I want you to be able to do it both ways. The first thing I could do is say, well, I want to get rid of the 4. So I could divide by 4, but then I have to divide the other side by 4, because whatever I do to one side, I must do to the other. And then my 4's will cancel, and I will get x is 12 divided by 4 is 3. Now remember what solutions do. Solutions solve. Solutions make true. So I should be able to take the 3, go back up into my original equation, right? 4x equals 12. I plug the 3 in. 4 times 3 equals 12. I plug the 3 in back where the x was, and it's true. Okay, so that's one way we should be able to do it. The other way is start back with the same one, and remember that to get rid of the 4, instead of dividing by the 4, I can multiply by the reciprocal of the 4, because my goal is to get x by itself, and I know that 1x is the same thing as x. Okay, so I'm going to multiply by 1/4, which means that on the other side I will also multiply by 1/4. And remember, it did not matter one bit whether I put the 1/4 in front of the term or 1/4 in back. It makes no difference whatsoever. Okay, so 1/4 times 4 is 1, and I end up with 1x or x, and on the other side, I have 12 over 1 times 1/4 is 12/4 is 3. I did it 2 different ways and came up with the same answer. That means that the 2 ways that I did it were actually equivalent, right? Dividing by 4 is the same thing as multiplying by 1/4. They're the same. Okay, let's do this one 2 ways. We have 5x equals 20. So we could divide by 5 and divide by 5, and then we would get x equals 20 divided by 5 is 4. Okay, and when we plug 4 back in here, we get 5 times 4 is 20, and we get back to our original statement is true. So now we're going to have 5x equals 20 again. And instead of dividing by 5, we're going to multiply by 1/5 and multiply by 1/5 on the end. Okay, and we're going to have 1x or x equals 20 over 1 times 1 over 5 is 20 over 5, which is 4. The 2 ways are equivalent, aren't they? Now, on this problem, I think it's definitely easier to multiply by a reciprocal instead of divide by a fraction. Now, dividing by a fraction is not wrong. It's equivalent to multiplying by the reciprocal, but to me it's a little harder because you're going to have to use the reciprocal anyway. Remember, if we divide by 2/5 and we divide by 2/5, then this goes to x, and now we're stuck. Now we say, well, what is 7 divided by 2/5? And 7 divided by 2/5 is the same thing as 7 times 5/2, because division by a fraction is multiplication by its reciprocal. Okay, so I'm going to show you why that's true. I was an old woman before somebody showed me why that was true. I'm going to show you right now. Okay, so here we had 7 divided by 2/5. But I don't like having a fraction in the denominator. So I am just going to, remember, I can multiply this fraction by 1. And I'm going to choose to multiply it by 1 in the form of 5/2 over 5/2. Guess what happens to the denominator now? And now 7 divided by 2/5 turns into 7 times 5/2. And it will always work that way. Okay, so now we can put a 1 on the bottom, and we have 35/2. Okay, now 35/2 is an improper fraction. But you're in algebra now, so they let you leave your answer in improper fractions. What is our rule? When do we know that we have to put it back into mixed numbers? Okay, well, the rule is this. If it started with mixed numbers, you should put your answer in mixed numbers. But if it started with improper fractions, you can put your answer in improper fractions. In this problem, it had neither. So I guess you can take your pick. I always leave it improper fractions if there's not mixed numbers in there, because improper fractions are easier. Okay, now on this one, I'm only going to do it one way. The book, I think, is doing it 2 ways, but I'm going to do it one way because I think it's the easiest way. So, anytime you see a mixed number and you're having to multiply or divide, you need to put it in improper form. So remember how we do that. 2 times 4 is 8 plus 1 is 9/4. And you're doing that because each one of those 2 wholes is 4/4. So 2 wholes would be 8/4 plus 1 more is 9/4. 9/4 x equals 3. So now I'm going to multiply by the reciprocal of the fraction that is tied to my x, but I'm going to do the same thing to both sides because that is my multiplication property of equality. This goes to 1. X is, now I've got a little bit of cancellation help. Divide the top by 3 and I get 1. Divide the bottom by 3 and I get 3/4. And I'm going to leave my answer 4/3. If I had to turn it into a mixed number, it would be 1 1/3. But I don't have to unless they tell me to, or unless I see a mixed number in the problem. All right, on this one, we're trying to get the x by itself, but I have a 3 in the denominator. What if I just multiply by 3/1 and multiply by 3/1, or just 3, and I'm going to end up with x is 27. The other way that we could do it is we started with x over 3 equals 9. We could realize that x over 3 is the same thing as 1/3 x. Isn't x over 3 the same thing as 1/3 x? And then I multiply by the 3 and the 3, and I get x is 27. It's really the same problem both ways, isn't it? All right, so here we have a mixed number in our problem. Since we have a mixed number in our problem, I would be tempted to put our answer back in mixed numbers. But I notice in our book that they don't put the answer back in mixed numbers. So I guess you can take your pick. Okay, but see, there's a mixed number in the problem, so I would tend to put the answer back in mixed numbers because that's a mathematical convention. If you start with fractions, you end with fractions. If you start with decimals, you end with decimals. If you start with mixed numbers, that's the way they want the answer. Okay, so I'm going to show you both ways because that's generally a math convention that kind of is pretty universal. That if you start with mixed numbers, your answer should be in mixed numbers. Okay, so here we have x over 2.5, which is the same thing as x over, and then 2.5 is 2 times 2 is 4 plus 1 is 5, 5/2. Okay, so I'm dividing by 5/2. If I'm dividing by 5/2, that is the same thing as what? Multiplying by 2/5. So basically, how can I get rid of this thing? I want to get rid of the 5/2. The 5/2 is in the denominator. So I'm going to multiply by 5/2 because the whole 5/2 is down here. So I'm going to multiply by 5/2 on both sides. Now, I'm going to end up getting 5/2 cancels 5/2, and I get x is 35/2, which, like I said, I would put into a mixed number form because you started with a mixed number, which would be 35 divided by 2 with 34 divided by 2 would be 17, so 17 1/2. Okay, so that would be one way to do it. Now, a little bit longer way to do it would be to come back here, and we have x over 5/2 equals 7. Okay, so a little bit longer way to do it would be, okay, we're going to end up rewriting this. And when we rewrite this, it's going to be division by 5/2 is the same thing as multiplication by 2/5. Okay, so we could put it in that form first. We still haven't gotten rid of the fraction. We just put it up in the numerator. So then I would still have to multiply by 5/2 on this side and by 5/2 on this side. This is going to cancel, and I would end up with x is 35 halves, which is 17 and a half again. Okay, so because the fraction was in the denominator, me putting just a 5 halves up in the numerator and multiplying both by 5 halves was a little bit quicker. But you need to do it the way that you're going to get it correct. Okay, so here's our last example, and we're about to start our practices. Notice that the p is divided by this whole quantity, 3 over 2. So what I can do is I can multiply by 3 over 2 on the top and multiply by 3 over 2 over here. Now the 3 over 2 on the bottom and the 3 over 2 on the top cancel out, and I get p is this times this. Well, I'm going to have to get this into improper form. 4 times 3 is 12, plus 1 is 13. 13 thirds times 3 over 2 is, 3's cancel, 13 halves. And 13 halves is the correct answer, but I would put it back into a mixed number form because you have a mixed number in your problem. So 13 halves would be 6 and 1/2, and that would be the answer. Okay, so you have to go with what your teacher's doing on that. This book is not taking the time to put it back into improper fractions, into mixed numbers, but basically that's the general rule. If you start with mixed numbers, you wind up with mixed numbers in your answer. But like I said, every time 13 over 2 is an acceptable answer, that's just a math convention that when we start with mixed numbers, we usually expect the answer to be back in mixed numbers. But that's a math convention, and if your teacher doesn't make you do that, that's okay. All right, here are practices A and B, and you need to copy them down and then pause your video and go practice those yourself. Okay, hopefully you did that and you have your answers. We're going to multiply by the reciprocal here, and we'll get rid of that. We don't need that anymore. Okay, so we're going to multiply by 5 thirds, but to make that legal, I have to come over here on this side and multiply by 5 thirds as well. Whatever I do to the left, I do to the right. This cancels out, and I get x is, now I have a nice little cancellation here. 27 and 3 are both divisible by 3 with a 1 and a 9. So I end up with 45 over 1, or just 45. Hopefully you got 45 for that practice problem also. Okay, so let's look at B down here. And we have a mixed number. We need to turn that into an improper fraction. So we're going to say 3 times 5 is 15, plus 1 is 16. So this is 16 fifths. So we have 16 fifths. Y is 32. Okay, so now I'm just going to multiply by 5 over 16, and on the other side, multiply by 5 over 16. This cancels out, and I get y equals, here's my answer over here. Now, I'm always going to put my 1 down here just to keep me straight. 32 and 16 both cancel with a 16 and a 2 and a 1, and 10 divided by 1 is 10. So your answers to A and B were 45 and 10. Hopefully you got them right. Let's come back with the last 2 practices. Okay, in this first one, I have a fraction in the denominator. Well, in order to get rid of a fraction in the denominator, I can just multiply by the same fraction on the numerator. So I'm going to multiply by 1/4 and 1/4. Okay, so the 1/4 on the bottom and the 1/4 on the top cancel out, and I'm left with 20 times 1/4, which is 5, and I get x equals 5. Okay, now going back to my original problem, okay, so I go back to my 1/4 on the bottom. This was my original problem, and then I put a 5 right here, and I check it. 5 divided by 1/4 is the same thing as 5 times 4, which is 20. And it works. Okay? So, the last problem. Hopefully you paused and you did this by yourself. Did you get a 5? I hope so. This one, if you haven't done it yet, pause your video because this is our last practice. Okay, so we're going to, first of all, change this. Either before or after you multiply, it doesn't matter as long as you do it at some point. You could just go ahead and multiply by 2 1/4. And multiply this by 2 1/4. And then change it into an improper fraction. That will be fine. Okay, so this cancels this. And we get x is 5 times 2 1/4. But 5 times 2 1/4 is 5 times 8 plus 1 is 9/4. And I can take my 5 and put it over a 1. And then nothing will cancel, so I'm going to get a 45/4. Okay, now 45/4 is the correct answer, but I had a mixed number. So it would be certainly good to put this back into a mixed number. It's a good practice anyway. So what is 45 divided by 4? Well, 4 goes into 45 4 one time, and then 4 goes into 5 one time. That's 11. 11 times 4 is 44. We have 1 left over, so 1/4. So the answer is 11 1/4. And we are done with lesson 24. And this is Mrs. A. And may God bless your day.